Hello everyone and welcome back to this series of videos on the Solow growth model. Specifically, until now, we've been talking about what we need to define the Solow growth models, what are the equations, what are the variables, what are the assumptions. And now we are going to move towards the core part of our Solow growth model, such as we want to find the conditions and whatever we need in order to draw the graph of the Solow growth model. And in order to do that, there are these Inada conditions that need to be tackled and explained so that we can reach a plausible conclusion to use in economic theory analysis. Let's begin by asking ourselves, why do we need the Inada conditions? And specifically, what are these Inada conditions? What do they do? First of all, let's start by writing down the definition. So in other conditions, in the Solow growth model, they are mathematical assumptions that they regard, so they regard the production function, regarding the production function. And if you recall, the production function is what we've been calling until now this function of capital and labor, the two factor inputs. And basically, they ensure a stable, positive, steady state equilibrium. The steady state equilibrium for capital. Because even though we've just been talking about output, what we care about, what is it that drives economic growth according to our Solow growth model, is capital accumulation. So basically, these Inada conditions, they guarantee that the economy does not get stuck at zero capital, so there is a way for it to proceed, or it does not grow infinitely without a bound, and they ensure this interior non-zero stable solution, and this is what we mean by a positive steady state equilibrium. If we want to give a very quick to steady state equilibrium, in case this term has never come up, when we talk about steady state, we mean a state in which variables do not grow from period to the next, from one period to the next. So, for example, it would be the case where we have capital in period t being equal to capital in period t plus 1. So now let's talk about what these conditions actually are. The first one is that both factor inputs need to be positive. Capital needs to be greater than 0 and labor needs to be greater than 0, meaning that inputs are essential if we want to find a definition of final output. Then we've already encountered this and we've already unpacked it thoroughly in previous videos. And here, when we are talking about positive but diminishing return to capital. So the positive part is captured by the first derivative of the production function with respect to capital, which effectively is the marginal product of capital, which has to be greater than 0, while the diminishing part is captured here. And we're basically analyzing the second derivative of the output function with respect to capital again. So we are taking the derivative, the partial derivative of the MPK with respect to capital, and this needs to be less than 0, meaning that as we add more capital, output is growing, but at a decreasing rate. So each additional unit of capital makes output increase less than the previous unit. And now, the two new big conditions that we need to insert are those that are actually going to allow us to have this stable interior solution. So first of all, the limit as capital goes to infinity of our marginal product of capital has to be equal to 0 because of depreciation. What this basically means is that output stops growing as capital approaches infinity. Why do we need this? Well, in other words, we are saying that the MPK approaches 0 as capital become abundant, and we know that the MPK refers to how much additional output occurs when capital increases. And this basically ensures that the economy doesn't grow infinitely. And then the second condition that we need to keep in mind is that the limit as capital goes to 0 of the MPK is going to equal infinity. Why? So here we had depreciation playing a role, depreciating our capital and preventing our economy from growing infinitely. And here we have the condition that allows us an economy starting with 0 capital, with low level of capital, to still grow. Again, because an economy starts with very low capital levels. And such capital is very productive. So basically, again, here we are talking about the MPK, which is extremely high when capital is scarce. And this condition allows the economy to start to grow. These four conditions that we've outlined, they are all satisfied by the Cobb-Douglas production function. And thanks to these, we can now move on in the next videos to draw our graphs for the Solow growth model in order to find an equilibrium level of capital and output.